Today, me and my team will walk you through how Dataiku and MLOps play a critical role in enabling our artificial intelligence, or AI factory here at BAE Systems, Inc. As part of our commitment to delivering responsible and scalable artificial intelligence solutions, we've built a framework that's centered around repeatability, automation, and flexibility, and Dataiku sits at the heart of it. Let's begin by framing what we mean by an AI factory. It's not just about automating machine learning, it's about creating an entire operational ecosystem for developing and deploying AI models efficiently, securely, and at scale. The AI factory helps us industrialize AI by providing repeatable, standardized pipelines and governance models. It's designed to serve multiple mission areas across the organization, ensuring that we can share best practices, minimize duplication, and accelerate delivery. At its core, the AI Factory framework produces four critical outcomes: speed to mission, delivering AI models faster and more reliably; quality and consistency, applying governance and best practices across teams; scalability, enabling more users and use cases to leverage shared infrastructure; responsibility, ensuring that data protection, bias mitigation, and explainability are part of every step. By aligning our people, processes, and technology through this factory model, we're able to increase the impact of AI while reducing risk and complexity. It becomes a flywheel that drives innovation throughout the enterprise. This slide outlines the core building blocks that make up our AI factory. Each one plays a vital role in how we develop, test, and scale AI solutions within BAE Systems. Our data pipeline is the foundation. It's semi-automated and built to handle everything from data ingestion and cleaning to integration and security. We use Dataiku to orchestrate this pipeline, allowing teams to pull from multiple sources and prepare the data quickly and safely. Governance is baked in, ensuring that what enters the AI lifecycle is high quality, trustworthy data. With algorithm development, we focus on turning that data into intelligence. Our algorithm development workflows enable teams to build machine learning models, everything from traditional classifiers to fine-tuned large language models. What's unique here is that we empower both advanced users and less technical teams through collaboration features in Dataiku. We also provide model comparison capabilities to help choose the best performing approach for each mission use case. Behind the scenes, we've built a scalable, secure infrastructure that supports both cloud and on-prem environments. This includes GPU orchestration, model deployment pipelines, and APIs for easy integration. Importantly, the infrastructure is compliant ready. Access controls, model audit trails, and CI/CD pipelines are standardized to meet both internal policies and external requirements. Finally, we have our experimentation platform. This is where rapid innovation happens. Team can prototype quickly, test new tools like LangFlow, fine-tune models, and refine prompt strategies using Prompt Studio. Because the environment is controlled and reusable, teams can safely test, fail, and iterate without starting from scratch each time. It brings agility to our workflows while maintaining oversight. These components work together to create a true AI factory, allowing us to scale AI from ideation to impact with speed, consistency, and trust. Now let's talk about the why we've invested in building an AI factory and what value it brings to the business. Speed to insight. First, time to value matters. In traditional AI workflows, it could take weeks to access data, prep it, and validate a model. With the AI factory in place, we shorten that time drastically. Teams have immediate access to curated data and reusable components, enabling insight generation in possibly hours, not weeks. Structured experimentation. We've learned that AI innovation needs structure, not chaos. The factory enables disciplined experimentation by giving teams access to sandboxed environments, pre-configured tools, and model comparison frameworks. This makes innovation repeatable, measurable, and aligned to real mission objectives. Operationalization and scaling. Many AI projects stall after proof of concept. Our AI factory bridges that gap by standardizing how we move from experimentation to production, whether that's deploying a model into an API or integrating it into a mission system. That operational consistency is key to delivering real-world sustainable value. Security and compliance. Given our industry, security isn't optional, it's mission critical. The factory embeds governance directly into every step, from data ingestion to model deployment. With built-in access controls, auditing, and lineage tracking, we ensure our AI products meet both ethical and regulatory standards. Culture and collaboration. And finally, this is about people. The AI factory helps scale knowledge, not just code. It brings together engineers, analysts, and mission leaders in a shared workspace with tools designed for all skill levels. This collaborative environment builds an innovation culture, one where experimentation is encouraged, but guardrails keep us aligned. In short, the AI factory helps us innovate faster, scale responsibly, and deliver AI that matters. This slide is foundational as it shows how we organize talent and responsibility across our AI factory, while also highlighting the operational gaps that MLOps helps us address. The image on the slide outlines the key role in our AI factory. These roles are not siloed. Instead, they work together collaboratively across the AI lifecycle. Let's walk through some of the most important ones. Data engineers are responsible for building and maintaining the data pipelines. They ensure the right data is available, clean, and accessible to teams across the organization. Data scientists explore data, develop models, and evaluate them. In our factory model, they work closely with mission stakeholders to translate business needs into ML experiments. ML engineers operationalize these models, focusing on the deployment, monitoring, and ensuring model performance remains consistent in production. AI governance leads create the governance framework, ensuring that models being developed and deployed comply with regulatory, ethical, and internal policy standards. These roles and many more form an interconnected team. Dataiku supports this collaboration by providing a single environment where all these stakeholders contribute without stepping on each other's workflows. The unifier is MLOps. It allows for these roles to work together efficiently. Without it, we end up with fragmented systems, manual handoffs, and poor governance and traceability. Next, Sarah Postjan, our MLOps lead at BAE Systems, will go into further detail about MLOps and why we chose Dataiku for our AI factory.
Thanks, Rana. And with this foundation, let's go ahead and dive into the critical role that MLOps takes in making our AI factory a reality. So what is MLOps? This quote from the Continuous Delivery Foundation really encapsulates what we're striving for here, treating these machine learning and data science assets as core components of our overall DevOps process. It's about bringing rigor, automation, and governance to the entire lifecycle. For those unfamiliar, MLOps isn't just about getting models into production. It's about the entire process, from data ingestion and model training to deployment, monitoring, and retraining. It's a cultural shift as much as it is a technological one. So let's take a look at where we were before embarking on this journey. Historically, at BAE Systems, our MLOps landscape has been a little bit fragmented. We've had a lot of isolated systems, which has led to inconsistencies in governance, compliance, and scalability. And it's been difficult to share resources in standardized environments. This really has created bottlenecks and slowed down our ability to deliver AI solutions quickly and reliably across the organization. So we realized that we need to create a more cohesive approach. And on the next slide, we'll dive a little bit more into that. Dataiku has provided us with that centralized platform, allowing us to broaden access to resources like GPUs and streamline collaboration. But we also recognize that open source tools offer a level of flexibility and extensibility that's really not possible to match. Our strategy has been to combine the best of both worlds. Dataiku's ease of use and governance with the power and customization of the open source community. So let's take a look at a concrete example, fine-tuning large language models. Dataiku's interactive environment, particularly its built-in support of Jupyter notebooks, is fantastic for rapid prototyping and experimentation. It seamlessly integrates with these Python packages that are driving innovation in this space. And importantly, Dataiku's infrastructure allows us to democratize access to expensive resources like GPUs across the organization, empowering more teams to participate. So leveraging this open source community, we've been exploring techniques to make LLM fine-tuning a little bit more accessible and efficient. And we've been particularly successful with LoRA, low rank adaptation. LoRA is really just a math trick that allows us to fine-tune large language models with significantly fewer parameters, making the process faster and more efficient. And as you can see, it's a parameter-efficient fine-tuning technique. This is crucial because it reduces memory usage and speeds up training, making it feasible to fine-tune even larger models on limited hardware. We can leverage the LoRA config package from the open source PEF library to implement this. So we're going to jump into a quick demo of a notebook we have running in Dataiku, where we will fine-tune Llama 3.2 1D on some Shakespeare data so that it responds in a more Shakespearean style and tone. So you can see here that we're importing the LoRA config package from the PEF library, along with a bunch of other open source Python packages that are going to help us do this fine tuning. We've got a copy of Llama 3.21b loaded to a local project folder in Dataiku. And then we're going to output the fine-tuned version of the model to another folder within Dataiku. And so we also load in the Shakespeare data. It's just basically going to be a data set with a bunch of different Shakespeare quotes that we will use to fine-tune this model. And then all of this is running on the infrastructure we have set up behind Dataiku. So this kind of shows you how anybody can come in here that you've got licensed in your organization and kind of use these GPU resources to do things like fine-tune models. And then down here, you can see that we're showing the output from this prompt that we're feeding it, BAE Systems, art as Tyrannus, so as thou art. And you can see before the model is fine-tuned, it just kind of gives a basic chatbot response, not really Shakespearean at all. But then we load in our fine-tuned model, and you can see that the response is now a little bit more Shakespearean in style and tone. So all that was done just using the hardware behind our Dataiku instance. So as you saw, the integration is seamless. Dataiku provides the environment, the infrastructure, and the governance, while LoRA and other open source packages provide the cutting edge capabilities, allowing us to efficiently fine-tune this open source large language model. So now let's switch gears a little bit and talk about data ingestion, specifically for our on-premise chatbot. So you can see here, our on-premise chatbot has the ability to select from a couple different open source models that we're running on premise. We have some prompt templates in here that the users can select from. And then we also have a number of collections that the user can switch to from the general chatbot. And in order to keep these collections up to date, we have these pipelines running in Dataiku along with open source tools. So We have the iLearn courses, policy documents, and things like that users can come in here and query for data specific to those collections. And this is where a robust data ingestion pipeline really becomes essential. So we've built these pipelines using a combination of Dataiku and open source tools like LangChain Community's document loaders, Selenium for web scraping, and Chroma for vector storage and search. These tools handle a wide range of data formats and sources, ensuring comprehensive data coverage for our on-premise chatbot. And they work with Dataiku, not as replacements for it. So once we have the data, we need to craft effective prompts for our LLMs. And Dataiku's Prompt Studio has been invaluable for this. It really allows us to quickly test and compare prompts across different models, identify the best performing ones, and then refine them before deploying them to the chatbot. And we're also exploring some more advanced agentic workflows with tools like Langflow. And Langflow is a visual tool for building and deploying LLM-powered agents, essentially autonomous systems that can perform tasks based on natural language instructions. It's important to understand how Langflow fits into our architecture. We're not running Langflow on top of Dataiku. Instead, we're leveraging the robust data pipelines in MLOps infrastructure we've built with Dataiku and open source tools to feed Langflow with high quality, well-governed data. And this allows us to build data-driven agentic workflows that maximize the value of our existing MLOps pipeline. So let's take a look at how we're using Langflow, powered by the outputs from our Dataiku pipelines. So here we have just a RAG workflow, basic RAG workflow that we put together with these drag and drop tools in Langflow. This is hooked up to some public MLOps data. And so you can see here that it's connecting to a collection that we've already ingested through a pipeline in Dataiku. And so we can ask a MLOps specific question like, what is the of a feature store? And this is going to use our on-premise version of Llama 3.18b, as well as the collection that's stored on-premise in a Chroma database to collect the information it needs to come up with the answer. And where this can become really powerful is if instead of hooking up to some public data, you have domain-specific or org-specific data that an LLM isn't going to necessarily be familiar with. And so lastly, I'm going to just quickly address the question of open source versus proprietary. So we see value in both. Dataiku provides this low-code experience, rapid upskilling, dedicated support and maintenance. They're all critical for enterprise adoption, while open source offers this community-driven innovation, customization, and it avoids vendor lock-in. So our strategy is to leverage the strengths of both to create this robust MLOps platform. And now we're going to move on to Dr. Auychai Suvanujasiri is going to do a little bit more of a deep dive into agents.
Thank you, Sarah. I think you can see from at the beginning from Lana to go over AI Factory. I think at the end, we build everything on top, start from data that is need to be clean, making sure owner, governance, that type of thing. We need ML platform that tie things all ecosystem together from hardware, from data, from scrubbing, everything to prompts. That is a lot of work behind the scene. And at the end, we can build automations. That is a key role for AI agent because the AI agent is kind of like built for specific tasks, something like this. But before we jump to detail, we would like to recap a little bit what is AI agents because actually it's a software that can think on its own, act on its own. Uh, it leverage AI to analyze informations, think about it, make a decision, and take actions for you. That type of thing that is the next level for automations. That's kind of AI agent that build on the top layer of the AI factory stack. And the example easily is AI agent can read all the document for you, summarize the key point, or even passing or extract specific informations for you. And the next, they can even save all the informations to the database or send back the email to you. That type of thing that we can automate using the AI agents. And how the AI agent work, I think you can see from this picture. Um, there is no magic. You need to have similar with human. When we assign a task or do something, we need to plan. We need to think. They have so many approach that we can break it down to be step by step or chain of thought or reflections, that type of thing that we need to plan for the agent first. And also, only plan is not going to be work. We need a tool. Sometimes we need calculator. Sometimes we need SQL agent. Sometimes we need some search capability that specific for use case. You can see not everything is fit in the same specific task. That's why we also build some custom using Python. I think Sarah already touched some of the capability that we build, fine tune that type of thing, or build some specific custom agents in Dataiku. And at the end, data is super important because without data, without um, the provide guideline feed to memory, short term or long term, agent is cannot function well. And at the end, we need to have some step that can take a look in terms of their action. If it not work, is it work? We can loop and feedback and reiteration along the way. You can see there is a lot of process involved behind the scene. For Dataiku is kind of like a platform that help us glue multiple things together from open source, from proprietary connection with the data, Oracle system, etc. I think that's kind of like the key ingredients for AI Factory because without the backbone of the platform to tie to hardware, tie to data, tie to data side that can make all complex tasks happen, I think life gonna be a lot harder than without this platform. Back to you, Lana.
Thank you, Weichai and Sarah. And I want to say thank you to our listeners for listening to how we at BAE Systems Inc. leverage Dataiku in conjunction with open source technology to build our robust AI factory. Dataiku, along with open source, are leveraged to democratize resources and build a robust, scalable ML and AI ops platform. This has allowed us to drive AI innovation and streamline business processes that are mission critical for our organization. Thank you.